It is well known that heparan sulfate and heparin interact with a wide variety of proteins, such as FGF, VEGF, and HGF. These complexes interact with receptors and cause biological activity. We artificially synthesize sulfated glycans by sulfating hyaluronic acid. The degree of sulfation was controlled by adjusting the reaction. The number of sulfation sites ranged either from 1.3 to 2.0 and from 2.1 to 3.9 in disaccharide units, named hyaluronic acid low sulfated (HALS) and hyaluronic acid high sulfated (HAHS), respectively. The binding properties of the sulfated HA variants to FGF2 were compared with those of other glycosaminoglycans. HAHS showed higher binding affinity to FGF2 than heparin and heparan sulfate. In contrast, HALS showed lower binding affinity to FGF2 than heparin. This indicates that the bonding strength of this material can be changed by controlling the degree of sulfation. In fact, sulfated HA showed a protective effect on the stability of growth factors, such as FGF2, FGF1, KGF, IL-6, and BMP2. Interestingly, this protective effect varied depending on the combination of growth factors and HA, with different degrees of sulfation. For instance, HAHS had no protective effect on BMP2, whereas HALS had no protective effect on IL-6. The biological activity of growth factors bound to sulfated hyaluronic acid is an important issue. The addition of sulfated hyaluronic acid to feeder-free human iPS cell cultures allows culturing of iPS cells without the addition of FGF2. When sulfated hyaluronic acid was added to a hybridoma culture, the production of antibodies significantly increased. Thus, sulfated hyaluronic acid not only binds to growth factors and stabilizes them, but also has bioavailability. In summary, the degree of sulfation is adjustable. Its features are similar to heparin. Hyaluronic acid, the raw material of this product, is made by microbial fermentation, so its source is animal-free. Sulfated hyaluronic acid is expected to be used as an alternative to sulfated polysaccharides, or as a material with new functions in various fields, such as wound healing. Thank you for your attention.